Here we have a problem where a ball is being dropped on a string and it's going to hit a peg as it swings down. And part A asks about the speed as it's at the bottom of its path, right here. Now, because the ball starts off, it's being dropped from rest, we can use energy pretty easily to solve this problem, actually. So it begins in a position where it's just got a lot of potential energy, and then at the very bottom of its motion, all of that potential energy will have been converted into kinetic energy. So first off, the potential energy can of course be found using the formula we usually use for that, mg, the mass of the ball, times the acceleration due to gravity, times the height that it falls from, or rather the height from the top of its motion to where it reaches the bottom, which in this case is just going to be L, because at the bottom of its path, it's just going to be, it can't be any longer than the length of the string. And since L's given to us, it's convenient for us to just use L for that. Because all of this potential energy will be converted into that kinetic energy, we'll set them equal to one another using the kinetic energy formula. So that's mgl is equal to 1/2 times, again, the mass of the ball, times the square of the speed that the ball's reached, which is what we want to find. The m's will cancel out, and then we'll want to multiply both sides of the equation by 2 to get the 1/2 out of the way, and then take the square root of both sides of the equation to get the v on its own. Doing this, we find that the speed of the ball at the bottom of its path is equal to the square root of 2 times the acceleration due to gravity times L. And that's all we need to do for part A. You can then just plug the numbers into your calculator using 120 centimeters for L, but be sure to convert that from centimeters to meters so that the units are consistent, as long as you're using 9.8 for G. You should find a speed of 4.85 meters per second. In part B, we're looking for the speed of the ball after the string has caught on the peg, causing the ball to swing around up to its highest point. Which I guess would be around here, which would be a total height of about twice the radius, or 2r. Now at this point in the ball's motion, it is neither at the original height or the bottom height, so there's going to be a mix of both kinetic and potential energy here. This means that the ball's total initial energy, mgl, will be equal to a sum of the new kinetic energy and the new potential energy. And I've used a little b subscript to indicate that the v and y variables are new and specifically refer to the ball's height in part B. Once again, we're looking for the ball's speed, which is going to be v sub b in this case. So we'll want to algebraically rewrite this equation to solve for v sub b. We'll first subtract mg y sub b from both sides of the equation. Of course, we can also cancel out these m's. And then we'll, again, multiply both sides of the equation by 2 and take the square root to get v sub b on its own. This is the equation we come up with, though keep in mind that y sub b is not a variable that's given to us by the problem. Of course, we can infer that it will just be the same as 2 times r, but r isn't something that's given to us either, though it can still be easily enough determined that r is just going to be the same as the distance between, or the difference in the distances between the length of the string and the distance between the peg and the fixed point where the string comes from. So r is just going to be equal to L times d. So we can rewrite y sub b, or 2r, as 2 times L minus d. So I've amended the 2 times L minus d in place of y sub b here. And now this is the final equation we'll have to use, because all the variables are given to us. Of course, just remember to convert the values given for L and d into centimeters, or into meters instead of centimeters, in order to keep the units consistent. So once again, if you plug all this into your calculator, then you'll get a value of 2.42 meters per second. And that is the final solution for part B. I hope this video helped you. If you have any questions, please leave a comment down below and I'll try to respond. If you have any suggestions for future videos, you can post comments as well, though for that I'd rather you send me a message. I've got my email and I've got a link to my Discord server in either the channel description or in this video description. But that's all for now, and I hope you all have a lovely day.